Good morning, everybody. So now this is another lecture on another separation method, and I'm going to speak about the sister of the chromatography, which is the capillary electrophoresis, and I will speak about the fundamental notions. Capillary electrophoresis is a separation method as chromatography, but the mechanism is totally different because in chromatography you separate using retention on the stationary phases, and in capillary electrophoresis the principle is based on the separation under an electrical field. So here you have the family of electrophoresis. So as chromatography is also a big family of separation method, and chromatography has different genealogical tree because you see the gas chromatography, for example, the liquid chromatography, and with the liquid chromatography you have the HPLC, you also have the ionic chromatography, the ion exchange chromatography, the ion pairing chromatography, the SEC chromatography. So this is a big family. This is similar with electrophoresis. Electrophoresis is a separation method based on the separation of compound in an electrical field. And there are also a genealogic tree. You can perform some different separation with different phenomena like isotachophoresis, isoelectric focalization, and I will speak about the zone electrophoresis. And we can perform this zone electrophoresis at different format, with paper, with gel electrophoresis, or capillary electrophoresis. And in my lecture, I will speak about the capillary electrophoresis, which is a miniaturized method. In electrophoresis phenomena. And with capillary electrophoresis, we can work with different mode. We will speak about the CZE, the capillary zone electrophoresis, but we also have different mode allowing to increase the field of application for the separation of compound. So you have the capillary gel electrophoresis, the capillary electrochromatography, or the micellar electrokinetic chromatography. We will speak on CZE first, and after I will show you some example of MEX and CEC. So here is the outline of my lecture. So we will speak about the phenomena, the migration phenomenon in capillary electrophoresis, especially the electrophoretic mobility and the electroosmotic mobility. These phenomena can explain the move of the molecules under an electrical field. So we will describe this phenomena in this lecture. The separation in CE, and especially the efficacy, CT, and the resolution, and a big part on the improvement of selectivity. Of course, this is a part on the optimization of the separation, and then the selectivity of the separation. And I will speak about some detectors, but not on capillary isoelectric focusing. So, what's the difference between CE, between capillary electrophoresis and HPLC? So we had a huge lecture on HPLC. And then we know that in HPLC we have equilibrium between the analyte, the mobile phase, and the stationary phase. You have this schematic representation of equilibrium in HPLC. Concerning capillary electrophoresis, we know that the separation is due to the migration of the compound under an electrical field. There are no stationary phases in capillary electrophoresis, and there are no pressure in capillary electrophoresis. This is only the separation with an electrical field. Then concerning the instrumentation, we have no pressure device as compared to HPLC and no injection device. Then this is a miniaturization device, and then this is a miniaturized format separation method. If this is a miniaturized format separation method, we have a low sample consumption and then also a low solvent consumption. This is an inexpensive method. And the major advantage of the capillary electrophoresis is the fact that there are high efficacy of separation as compared to HPLC. But the problem is that for UV detection, for example, we have a low sensibility of detection because we are in a miniaturized format. So here is the principle of the capillary electrophoresis. So you see in the principle of capillary electrophoresis, this is quite similar to the chromatography, but there are huge differences. First difference is this is a capillary here and not a column. The capillary is an empty tube. There is no stationary phases. This is only filled with a conductive liquid. A conductive liquid named background electrolyte, BGE. The background electrolyte allows to perform an electric field between the anode and the cathode. So you have also a detection, a detector. The detector is generally in the capillary, at the end of the capillary. And after that, you have the, of course, the computer system to obtain the electrophoregram. So we perform the injection of the compound, as in chromatography, of course, and we applied a voltage. A high voltage generator allowed to apply the voltage, and we have the separation of the different compounds due to migration of the separation. There is no retention in that case. And using the detector, we obtain the electrophoregram. So you understand that there are some properties, and these properties allow the separation. The first properties is the background electrolyte. So the electrolyte, the salted solution, which allow to perform the electrical field. And after that, you need a high voltage generator. So on the experimental device, you understand that you have some electrolyte vial here and here. You have your capillary represented in red. So this is an empty tube, a very small empty tube. And here you have the detection at the end of the capillary. Not in the total length, but generally in the I think this is 6 or 10 centimeters at the end of the capillary, before the end of the capillary. And you have here some electrodes with a high voltage generator to allow the to apply high voltage. The classical capillary are bare fused silica capillary. We will speak about that because it is very important to see that. The length of the capillary is generally 20 to 100 centimeters, and the inner diameter is in 20 to 100 micrometers. And you see, this is a very small, very miniaturized system. The voltage is between 5 to 30 kilovolts, which is a high voltage.